Okay, so if you're at home, please take a moment to copy down these expressions for your warm-up and then pause the video and work out the problems. Okay, here's the answers to problems 1 through 6. Go back and check, make sure you didn't make any errors, and correct any if you did. Okay, so we're on the table of contents. Today's date is 8/15. And whatever your next page number is in your notebook is going to go here. So take a moment to fill that out and pause the video, please. Okay, whatever page number you wrote in your table of contents is also going to go here. Lesson 1.1, solving two-step equations. Your objective is student will be able to solve simple equations. So please take a moment and pause the video and write that in your notebook. Okay, so first thing we want to cover is what is an expression versus what is an equation. So looking at your two examples here, this is an expression. This is an equation. What is the obvious difference that you see? Of course, you probably said the equation has an equal sign, and you are right. Okay? So an expression is a combination of numbers and letters, and you can really only do anything with this is if I tell you, okay, maybe x is equal to 2, then you could plug 2 in for x and tell me that the whole thing is equal to 7, because 2 times 2 is 4, plus 3 is 7. So with an expression, you can only evaluate. Okay? And evaluate means, there's kind of a STEM word in there, you're going to tell me what the value of it is after you plug the number in. With an equation, you're going to solve. So what that means is you are going to get x by itself. You're going to try and figure out what number can I plug in for x that will make this side of the equation 9. Okay? So you can probably do some mental math right now and figure, okay, well, by guessing and checking, I could plug in 2 times 3 is 6, plus 3 is 9, so x would have to be equal to 3. Well, they're not going to all be that easy, so we have to set up some steps so that we can do the same process every single time. So take a minute to pause and copy all that down in case you need more time. Okay, we are going to be working with one variable equations, so let's talk about what that means. Here's an equation. Oh, let's put 6. Okay. I only have one letter here. I only have an x, so that is a one variable equation. Later on in the semester, we're going to be doing two variable equations, and they're going to look like this. Okay, so notice that I have two variables. I have y's and x's. So this is what we're going to be working with in this unit. Only one letter. Okay, so moving on. You're going to solve using inverse operations. Inverse means opposite. Okay, so inverse operations, for example, if I am doing addition, then the inverse or opposite of addition is, you probably guessed it, subtraction. Also, if I'm doing multiplication, the inverse is, you probably already know, is division. Okay, so whatever I see, I'm going to do the opposite of that. Opposite operations are used to isolate and solve for the variable. Okay, so here's something that you need to know. when you're solving, you're going to do PEMDAS in reverse order. So instead of doing PEMDAS, you're going to do, the P is going to go at the end, E, M, D, A, S. Okay, so we're going to do it backwards when we're solving. So first of all, I'm going to undo any addition or subtraction that I see. Okay, so when you're solving for equations, the very first thing that you should do is draw a line down your equal sign. Now I have two sides of the equation. This side, x plus 5, has to be equal to negative 13. So they're equal sides. Okay, the next thing you need to understand is that what you do to one side of the equation, you have got to do to the other side. And here's an example of why. I'm going to pick a simple equation, a true statement. 3 is equal to 3. Okay? So, true statement. Well, what happens if I only add 1 to one side of the equation? Then all of a sudden I've got 3 is equal to 4. They're not equal anymore. It's not true anymore. But if I add 1 to the other side as well, all of a sudden they're equal again. They're balanced. So whatever I do to one side of the equation, I have to do the exact same thing to the other side. Okay? So keeping that in mind, let's take a look at our equation. So my PEMDAS in reverse says I'm going to do any addition or subtraction first. Your whole goal in life right now is to get the x all by itself, which means I can see that 5 is being added to x right now. I want to get rid of that plus 5. I have to make it go away because x has to be by itself. So what I'm going to do is I'm going to subtract 5 here, but if I subtract 5 here, I also have to subtract 5 from the other side. Okay? So what you're doing now is you're going to add everything up. X plus no x's, there's nothing here. X plus no x's is just x. That just stays there. My next step, though, 5 plus negative 5, which is 5 minus 5, that's going to be 0. That's what you want to have happen. You want that to go away. Okay, so then I have equals, and negative 13 minus 5 is going to give me negative 18. Okay, let's go back and see what happens when we plug negative 18 in for x. So let me clear this up a little bit up on the top. If I take this negative 18 and plug it in for x over here, that will give me negative negative 18 plus 5 equals negative 13. And yes, they are equal. So that is the correct answer. All right, let's try another one. Pause at any time if you need to, if I'm going too fast. All right, my next example, I'm going to start by drawing my equal sign. Okay, I see a big red flag here because as I read this right or left to right, it says n minus negative 4. I have a double negative going on here. And as you know, two negatives make a positive, so I'm going to change my equation to say n plus 4 equals negative 8. Okay, trying to get the n this time by itself. My variable is an n. Okay, I can see that 4 is being added, so I want to get rid of the 4. So I'm going to do the opposite of add 4. I'm going to subtract 4 from both sides. All right, so I'm adding. N plus no n's is still going to give me n. 4 minus 4 is 0, so that kind of just goes away. And then on my right side, I have equals negative 12. Negative 8 minus 4 is negative 12. And if you would like to go back and plug it in, negative 12 minus negative 4 equals negative 8. Again, these two negatives right here are going to turn into a positive, and that does come out to be negative 8. All right. Similar but different because I have a different operation going on here. So same thing, find your equal sign, draw a line. Now, instead of being added or subtracted from x, notice that these two terms are together. That reads 8 times x. Okay, so those are being multiplied. So the only way I can get rid of that 8 is to do the opposite of multiply, which is divide. So I'm going to divide both sides by 8. That's going to cancel because 8 divided by 8 is 1, and as you know, 1x is the same thing as x. Okay, so my x is going to stay because the 8's have gone, and now I have to divide negative 32 by 8 also, which is going to give me negative 4. Again, if you would like to plug in your answer for x, 8 times negative 4 does equal negative 32, so everything is good. All right, next one. Same thing. This reads negative 9 times x being multiplied equals negative 36. So I have to, in order to get rid of the multiplication with the negative 9, I have to do the opposite, which is divide. So negative 9 divided by negative 9 cancels because that is negative, that becomes positive 1. And x is equal to, I forgot to draw my line, positive 4. X equals positive 4. Okay. Very similar to the multiplication, except now I have division going on. Okay? So this divider bar, this fraction bar means division. So I have x being divided by 5. So instead of being divided by 5, I'm going to multiply x by 5, and I'm also going to multiply the other side by 5. Make sure you're keeping your 5 in the numerator because this is really a 5 over 1. So if I wanted to, I could put a 1 in the denominator, and this would be my 5 that I'm multiplying by each time. But I don't need to do that. If you want to do that, that's fine. If you like the fractions, I'd rather stay away from them if I possibly can. All right, so what's going to happen here is the 5 in the numerator is going to cancel with the 5 in the denominator. And that is going to leave me with x equals negative 30. And again, if you want to go back to your original equation and plug in negative 30 over 5, it does equal negative 6. All right, example 6. Let's talk about this guy for a second. I got a negative x over 7. So my question to you is, where does the negative go? Does it go with the x or with the 7? It actually doesn't matter, and here is why. I can put the negative with the x, and I can put the 7 on the bottom, which would make the 7 positive, because I only have one negative there, okay? But a negative and a positive makes a negative, so that turns out to be this guy, okay? I got a negative upstairs, a positive downstairs. That does turn into negative 7 over x. What happens if I have the negative on the 7 and the x is positive? Same thing. One's positive, one's negative. It's still going to turn into negative 7x over 7. Okay, so all of these three things are equal. Okay, so keep that in mind when you're working this type of a problem. Okay, so I am going to rewrite this problem, and I'm going to put the negative with the 7, because it really doesn't do me any good to put it with the x, because I'm trying to solve for x, and by putting a negative in front of it kind of makes it confusing. So I'm going to put the negative with the 7 and rewrite it. Okay? So the opposite of dividing, this reads x is divided by negative 7. Opposite of divide is multiply. So as long as I multiply both sides by negative 7, I'm okay. I can do it as long as it happens to both sides. So these guys are going to cancel. That leaves me my x equals 36 times negative 7. I'm going to have to do a little math here. So 2 42, that's going to be 252, negative 252, because this number is negative. Final answer. And you could plug that into your equation and find that it is equal to 36 when I divide negative 252 by 7. All right, so now we have two-step equations. Please take a moment to pause the video to write down the text in blue. Okay, so they're called two-step equations because you actually have to do two things to get x by itself. All right, so keep in mind we're doing PEMDAS in reverse. PEMDAS. So the first thing I have to look for is any addition or subtraction that's being done to my x. So my x term is here. That's the thing I want to get by itself. I can see that 2 is being added to that term. So I want to get rid of that adding 2 by subtracting 2 from both sides. Okay, so keep in mind we're adding. So negative 4x plus no x's is still negative 4x. These guys are going to cancel. 2 take away 2 is 0. That's what you want to have happen. You want that to go away because I'm trying to get the x by itself. And then on this side, I'm going to have positive 2. Okay, same as before. X is being multiplied by negative 4. That means 4 times x. So I have to divide, which is the opposite of multiply, both sides by negative 4. So these negative 4s will cancel. So x is going to be equal to negative 2/4, which reduces to negative 1/2. All right. Next one. Take a moment. Try and solve it on your own. You're going to do the PEMDAS in reverse. So this is the guy you're trying to get alone. Try and take it from there. Okay, take a second to check your answer. And pause it if you didn't get it correct and go back and fix your work. Okay, why don't you go ahead and try these examples on your own. Oh, well, let's just do them together. I think we need a little bit more practice with this. All right, so I'm going to draw my line down my equal sign. Here's my x, so I'm trying to get this guy by itself, which means this negative 5 right here has to go away. So I'm going to add 5 to both sides. My negative 3x is going to come down because there's nothing there to add to it. Okay, these are going to cancel because 5 and negative 5 add to 0. And then on my right side, I have negative 9. Okay, again, this means negative 3 times x. That's multiplication, so I have to do the opposite of multiplication, which is divide. Which makes these two cancel. Negative 3 divided by negative 3 is 1. And negative 9 divided by negative 3 is 3. Final answer. All right, there's one with a fraction on it. So same thing, draw your line, find where your x is. Circle the term or square around it or whatever, a rectangle. Okay, I see a negative 5 right here. All right, I have to do the opposite of subtract 5. So I'm going to add 5 to both sides. That's going to make those 5 and negative 5 cancel. So x minus 3 is going to come down. And that's going to equal 20. 15 and 5 are 20. Okay, the opposite of divide by 3 is to multiply by 3, both sides. These will now cancel, so x is going to be equal to 60. Okay, take a minute and try and solve those on your own. Go ahead and pause the video now and do some work. Okay, go ahead and check your answers. Your first answer, you should have gotten x equals negative 64, and your second answer, you should have gotten x equals 6. If either of those are wrong, please pause the video and try to follow my work until you can understand where you made your mistake. Okay, so this is a quiz for you. Go ahead and try. You can either do these, you can either do the ones on the left or the right, but it should be part of your notes. So you can either do these on this side, or you can do 1 and 2 on this side. It's your choice. So add that to your notes. And then here's the answers for that. Oh, that's not the answers. Okay, so never mind, just go ahead and add those to your notes. And then Unit 1.1, solving two-step equations homework, can be found the same place that you found this video. Hope you're feeling better, and see you tomorrow.